Morning, one and all. Welcome back to the video lecture series for signal systems. This is Dr. P SREENIVASUlu. Today, we are going to discuss about the Laplace transform of standard signals. Now, first one you see, already we have seen Laplace transform of step signal, ramp signal. Now, if you go, the Laplace transform of sine signal. Now, f of t is equal to a into sine omega naught. F of t is equal to a into sine omega naught t. Usually it is a into sine omega naught u of t. Now, this sine omega naught t, you can write into complex exponentials. So, you know, sin x is equal to e power jx minus e power minus jx by 2j. Here instead of x, we have omega naught t. So, we can replace this sin omega naught t is equal to 1 divided by 2j e power j omega naught t minus e power minus j omega naught t. Now, it is the sin omega naught t representation in terms of complex exponentials. Now, if you apply Laplace transform on both sides, so Laplace transform of sin omega naught t is equal to, you can separate these terms, Laplace transform of e power j omega naught t minus Laplace transform of e power minus j omega naught t into u of t also. So, already we know what is the Laplace transform of e power at u of t. What is the Laplace transform of e power at u of t? Previously, we know. What is the Laplace transform of e power at u of t? It is 1 by s minus a, and corresponding ROC is, real part of s is greater than a. We have a pole is at s is equal to a. So, it is a right-sided signal. So, the ROC is also right-sided. So, you can write parallelly real part of s is greater than a. Now, if you observe here, instead of a, we have j omega naught. It is you need to notice. Next, coming for e power minus at u of t. E power minus at u of t. Now here, e power minus at u of t, the Laplace transform is 1 by s plus a, and corresponding ROC is real part. Again, there is a pole is at s minus a. So it is a right-sided signal. ROC is real part of s is greater than minus a. So, based on these standard Laplace transform formulas already we discussed, now you replace that content here. Now, if you replace this content, instead of a, we need to replace j omega naught. So, s minus j omega naught, s plus j omega naught. So, you can, after getting this one, a by 2j, 1 divided by s plus j omega naught minus s plus j omega naught, you take LCM here, s plus j omega naught minus of s plus j omega naught. So, s gets cancelled, you will get 2j omega naught divided by, here a minus b into a plus b, a square minus, j square is a minus 1, so minus into minus plus, s square plus omega naught square. Now, 2j gets cancelled, so finally, a divided by omega naught, a omega naught divided by s square plus omega naught square. Now, what about ROC? Previously, we know we have a pole is at s is equal to j omega naught. So, real part of s is greater than a. So, real part of s here, instead of a, we have a j omega naught. So, real part of s is greater than j omega naught, or s is greater than j omega naught generally, because we have a pole it is at s is equal to j omega naught. So, s is equal to j omega naught here. Our ROC is S is greater than j omega naught. What is the S? What is the S? Generally here S is a sigma plus j omega naught. So here in this particular problem, there is no real part, only we have imaginary part. Now, what is the real part here? 0. So you locate a pole at sigma is equal to 0 and the pole is occur at omega naught on imaginary axis. So you draw a line parallel on the y-axis, it is the ROC. Or you can write simply real part of S is greater than 0 because sigma is equal to here 0. For this also, S minus j omega naught also, we have a pole is at minus j omega naught, but sigma is equal to 0. So that's why the ROC, common ROC is here. Real part of S is greater than 0. The ROC is important. Here he has not drawn this. You take S plane, you draw the on the x-axis real part of S, on y-axis imaginary part of S, and you locate these poles. We have a pole is at S is equal to j omega naught and S is equal to minus j omega naught. We have a little bit of doubt where you have to locate these poles because sigma is equal to 0 on the imaginary axis means that is on the y-axis. You locate at j omega naught one pole and minus j omega naught another pole, and then you show on right half of the S plane, it is nothing but our ROC here. Now coming for another problem, if you observe here, a damped cosine waveform, So f of t is equal to e power minus at cos omega t. F of t is equal to e power minus at cos omega t. Here we can solve this problem in two ways. One way is by applying properties. Another way is by applying direct rule. So again, what is the direct rule here? You need to express this cos term in terms of complex exponentials. If you apply this cos in terms of complex exponentials, so what is the cos? E power j omega t plus e power minus j omega t by 2. Cos omega t is e power j omega t plus e power minus j omega t by 2. Now here, you can multiply with e power minus at. E power minus a is a common, e power minus t is a common. So you will get a minus j omega into t plus, here if we take minus is a common, a plus j omega into t. So 1 by 2 e power minus of a minus j omega into t plus e power minus of minus a plus j omega into t. And as usual here, what is the Laplace transform of e power minus at formula? You just take that formula. What is the Laplace transform e power minus at u of t? What is the Laplace transform e power minus at 1 by s plus a, and ROC is real part of s is greater than minus a. Whenever we have a, we are going to write it s is equal to a plus j omega whole. Now you substitute the data 1 divided by s minus a. So s minus a, s plus a. Now you see here e power minus of e power minus at. Minus at means what? S by s minus a. S plus a. It is also e power minus at 1 by s plus a. Now you substitute this one and you can take LCM for this. And finally, if you observe here, what is the ROC? Always you don't forget about this ROC. What is the ROC? We have a pole is at S is equal to minus a plus j omega. We have a pole is at S is equal to minus A plus j omega. Now you look at S is equal to minus A and you draw a ROC, and where we have a minus A on the real part of X and j omega on imaginary part of X, imaginary part. And similarly here second root also there is a complex root. Again it is also S is equal to minus A and minus j omega. You look at these two poles, because ROC does not contain any pole, it is also you keep in mind, and take the S plane and draw the on x-axis real part of S, on y-axis imaginary part of S. We are going to look at these two poles. At one pole, both poles are existing in the left half of the S plane, because at S is equal to minus A, and corresponding one is a complex j omega, another one is complex minus j omega, and you locate these two poles and draw a parallel line to the imaginary axis, and this right sided ROC, because real part of S is, here not a real part of S, S is greater than minus A plus j omega, minus A minus j omega. So that's why you draw the line and you locate that ROC. It is about simply if you observe this one, what is the, by using the properties also, we can see, I will give the idea. What is the cos omega t Laplace transform? If you not, so far you have done cos omega t Laplace transform, you can better you calculate again. So cos omega t Laplace transform, like cos omega t u of t Laplace transform is S by S square plus omega. Now, according to this property is a shifting in S domain property. Shifting in S domain property. Cos omega t, you can assume some x1 of t. According to shifting in S domain property, e power s naught t into x of t is equal to x of s minus s naught, e power minus at x of t is equal to x of s plus s naught. So here simply you replace s with s plus a. You replace s with s plus a. So whatever the analysis we have done, it is somewhat complicated, but we have a standard formula cos omega t u of t. Simply you write Laplace transform cos omega t u of t. It is a s by s square plus omega square. In place of s, you replace s plus a. It is by using properties. Okay. Today I am stop this class. We will see the next class about this Laplace.